So this video is to teach you how to get the formulas of compounds. So we did elements in the first video, so this is video 2. Now, the first thing to note is that you need to know the number of electrons lost or gained by any atom on the periodic table. All right, so let's have a look. How do we know that? So it is to do with the charge of the ions. So the group 1 elements will all end up with a plus charge, right, because they lose 1 electron. Group 2 will end up with a 2 plus. Group 3 will end up with a 3 plus. It's group 4 can be 4 plus or 4 minus, but you probably won't see that too often, right? So then you have the non-metals. So they will end up, a nice color, pink. Okay, so group 5 will be 3 minus. Group 6 will be 2 minus. Group 7 will be minus. And then group 0 obviously don't form ions. Okay, so we're going to come back to that a lot, right? So that is really important to know. The charge of the ion of any atom on the periodic table. So how do you get a formula? Now, the first thing is you need to know the name of the substance. So we're going to use some of the substances that we've used, or the chemical equations. Sorry, it's quite late. Chemical equations that we need to know for the GCSE. So let's see. What about an alkali metal and water? Okay, so for example, let's do potassium and water. So you should know that if you react potassium with water, you will get potassium hydroxide and hydrogen. Now, we know from the last video that the formula of any element there, right, potassium is K and hydrogen is H2, and hydrogen is H2 because it's a diatomic element. So that was in video 1. So we're going to look at the compounds now. Now, and I forgot about hydrogen, actually. Hydrogen is kind of weird because even though it's a non-metal, it actually forms a single positive charge, right? So it's a plus. So its charge would be plus, okay? So it ends up as H plus. It loses its 1 electron. So that might be useful to know. So potassium and water. So we're going to just look at the compounds. Oh, I've just picked a bad one. I'm going to change that. Okay, I'm going to have to come back to that one. I'm going to start with a different one. Let's see, something that's easier. So we're going to start with one of the halogen displacements. So say chlorine plus potassium bromide gives you bromine plus potassium chloride, because the more reactive halogen takes place of the less reactive halogen in the compound. So let's look at the formulas of potassium bromide and potassium chloride. So first thing to note is look at the formula of each of the elements, the symbol for each of the elements present in that compound. So we've got potassium and bromine. Now, it's not bromine Br2 because it's part of a compound. Bromine is only Br2 when you have the element, when it's on its own, only bonded to other bromines. So we've Br and we have K. Okay, so let's have a look. So K and Br, right? So they are going to be part of the formula of potassium bromide. Right, so I'm going to circle them, K and Br. Now, the next thing to look at is the charge of their ions, all right? So they are plus and minus. So if we scroll down, okay, so we're going to put the charges in. So that's K plus. I'm going to try and use a different color for this. Br minus, right? So K plus and Br minus, right? Now what we're going to do is, so they are going to combine, as we did in ionic bonding, they are going to combine in a ratio such that the charges cancel out, okay? So how you do this kind of systematically for a formula is you lose the charge, right? So you're never going to have pluses or minuses in the formula. So we're going to leave those, and then any numbers left behind, which are none, we're going to drop them down and swap them over. Now, in this instance, there are no numbers. It's effectively the number 1, but it's not there. So that's going to be K, B, or. So we're going to put them together. So they're just going to be in a 1-to-1 ratio. Now, potassium chloride. If you look at the periodic table, you've got K and Cl, right? So they're going to be part of the formula of potassium chloride. In this instance, you have got K plus, Cl minus again. So if you look up at the periodic table, group 1 and group 7. So, and then we're going to do the same. We're going to lose the charge, and then any numbers, really, if we've no numbers left, we just put them together. So cancel out the charges, and that gives you KCl. So that is the formula of potassium bromide and potassium chloride. And actually any group 1 and group 7 element will always combine in a 1-to-1 ratio, right? So for example, if you pick any of the elements from group 7, or from group 1. So if we say have sodium and we have iodide, they are going to be NaI. So they'll always react in a 1-to-1 ratio, all right? Now, what happens when you have group 2? Okay, so what if you have, say, a compound made from a group 2 element and a group 7 element? So let's say magnesium chloride, right? So again, we're going to write down the formulas. And we're going to put in the charges for each of these. So magnesium now, if you look at magnesium, it's group 2 in the periodic table, okay? It's a 2+ ion, and chloride will always be a single negative. So let's put those in. So we've got 2+, and we've got a minus. Now again, we're going to get rid of the charges. So you can never have pluses or minuses in the formula. So I'm going to rub those out. So we're losing the charge. And now what we're going to do is we take, I'm going to just capture that. Okay. And take that, and hopefully I can move that down. So it's a drop and swap scenario here, right? Now we've no number. There's nothing here. Okay, so there's nothing to drop and swap. So actually, what we're left with is MgCl2. Now, if you think of the ionic bonding, magnesium has 2 electrons to lose. Chlorine atoms have 1 electron to gain. So you're always going to need 2 chlorines for every magnesium. All right, so this, we did a wee bit in ionic bonding. Okay, so let's have another look at this. What about if we have a group, let's see, group 1. So group 2 plus group 7 will always combine in a 1-to-2 ratio. Okay, so for example, calcium iodide will be CaI2, and it's not because iodine is diatomic. Just be very careful about that. It's to do with the ratios of their ions, so just be careful about that. Okay, and just to remind you, sodium iodide will be NaI, not NaI2, because group 1 elements, alkali metals, and group 7 halogens will always combine in a 1-to-1 ratio, because because group 1 elements lose 1 electron and group 7 elements gain 1. Okay, so let's look at a few more of those. So what if we have, let's have another look. Let's say we have a group 1 element and a group 6 element. Okay, so let's say we have lithium and we have oxygen. What's going to happen when lithium and oxygen combine? So lithium and oxygen will give you lithium oxide. That's going to be the name of it. Okay, and again, we're going to put the symbol. So it's going to be Li and a certain lower down number, and O and a certain lower down number. So here we've got, right, lithium ions have a single positive charge. Oxide ions have a 2 minus charge. So we're going to, again, get rid of the charges because they don't appear in the overall formula. They'll always add up to 0. And we're going to drop and swap any numbers that we've left. So here we've a 2. So I'm going to take it and I'm going to drop it down and I'm going to swap it over. So now we have the formula of lithium oxide is Li2O, right? And group 1 and group 6 elements will always combine in a 2-to-1 ratio. And again, if you think back to ionic bonding, that's because lithium atoms lose 1 electron, oxide ions gain 2, so you're always going to need 2 lithiums for every oxygen, and that's reflected in the compound that you make. Okay, one more, and then I'm going to get you to do some practice. Okay, so we've got, last one is, let's say we have a group 2 and a group 6. So let's pick any group 2 element. So let's pick strontium, right? So we can pick any, this will work for any of the group 2. So strontium and group 6, let's pick sulfur this time, right? So strontium and sulfur, how will they react together? What kind of compound? What will the formula of their compound be? St, strontium, and it's going to be sulfide because you always end with IDE when you have a non-metal atom in the compound. So strontium is SR and sulfur is S. Now the charges of strontium is 2 plus, and for sulfide it'll be 2 minus. So now we're going to again lose the charges and we're going to drop and swap. However, we're going to have to do, so let's pick that one first. So that's going to be dropped and swapped over here. And then this one, oops, I'll do that. This one is going to be dropped and swapped over here. So we're going to end up with SR to S2, except they're both the same number. So actually, again, if you end up with the same number, they cancel down, okay? So you'll actually end up with S or S. And again, this is to do with the ionic bonding. So strontium has 2 electrons in its outer shell, so it'll lose 2. Sulfur has 6, so it gains 2. So they'll always react in a 1-to-1 ratio. So group 2 elements and group 6 elements also react in a 1-to-1 ratio. So for example, magnesium oxide will have the formula MgO, okay, because there'll always be 1 magnesium for every oxygen. So that is fixed, that will never change. Okay, I'd like you to have a go at, let's see, what have we got? Those ones are too hard. I'm going to write a few and then I'm going to pause and just do the formulas. So what I'd like you to try is these ones. So let's see, sodium oxide, potassium sulfide, lithium bromide, magnesium fluoride, and then some that we haven't met. Calcium oxide. And now these, think about how these might go. Aluminium, nitride and aluminium oxide. Okay, so pause the video here and I'm just going to have a go with those, and then I'm going to put the answers up. All right, so sodium oxide is a group 1 and a group 6, so you need 2 sodiums for every oxygen. Potassium sulfide, that's like sodium oxide, it's a group 1 and a group 6, so you're going to need 2 potassiums for every sulfur. Lithium bromide is a group 1 and a group 7, so they will react in a 1-to-1 ratio, and you'll have LiBr. Magnesium fluoride. Magnesium is group 2 and fluorine is group 7, so they'll always react in a 1-to-2 ratio. Calcium oxide is a group 2 and a group 6, so they will always react in a 1-to-1 ratio. Aluminium is group, right, I'm just going to do aluminium quickly. So aluminium is 3 plus and nitrogen is 3 minus. So actually, if we lose the charges and we see they have the same number, right, they will cancel down and it'll end up as a 1-to-1 ratio. And you will have AlN for aluminium nitride. And aluminium oxide is Al 3 plus, and oxygen, because it's in group 3, have a look at it. And oxygen is 2 minus. And now let's lose the charge. And we're going to drop and swap charges. So the 3 in the aluminium charge is going to end up down by the oxygen. And the 2, that was the charge of the oxygen, is going to drop and swap down to the aluminium. And you will end up with Al2O3. Okay.